Welcome to this session on vector database. So of late there has been a huge buzz about vector databases and what they are. Uh, the Google definition for a vector database says that it's a type of database that stores data as high dimensional vectors, which are mathematical representations of the features or attributes. So essentially a vector database is any database which could provide storage to the mathematical representations, which are nothing but the vector representations of the text that a user enters in the search for the GPT. That's all a vector database is. Now there are many vector databases out there. There are certain databases like Postgres which also provide extensions that can be enabled for it to function as a vector database. However, there are other startup companies which are coming up with their native vector databases, like Pinecone is a leader in this space. There are others like Viviate, Milvus, so on and so forth. But in this session, we'll just basically understand what is a vector database. I will take an example vector database, which I found really nice and free. And then we will see how to create vectors using the embeddings API of OpenAI, and store those vectors and then search on those vectors using the similarity score. And then once we have a fair understanding of what a vector is and how it's stored and how it's searched upon, then we will go to a sample chat application that I built, which can be easily scaled up to an enterprise GPT using the vector database approach. So we'll start with a set of queries, and here's the first query that I have. In fact, before we go to the queries, let me first show you a vector database that was of recent interest to me, and it's called Superbase. It is nothing but it's built on open source Postgres underneath, and it's on the cloud, of course, and it's pretty easy to use. I took the free tier of Superbase, and so far I've had no issues in terms of storage or runtime, execution, so on and so forth. So using Superbase, I just created a few tables, vector tables, that I will share with you. So I'm in the table editor of Superbase, and it is pretty similar to any other vector databases that are built on Postgres and other native vector databases like Pinecone, etc. So here on the left side, you'll see two tables that I created. We'll first go through my vector table that I created a sample table, and what I did is that I created two columns. In fact, let me show you the create table statement for it. Yeah, so this is the create table statement that I wrote. So to create the vector table, my vector table, and I basically added a key, primary key as ID column, and the content, which is a text data that a user will input, and then the vector representation of data type vector. Now 1536 is usually the dimensions that OpenAI uses to translate any content text into a high dimensional vector space. Different embeddings models will come with different dimensions here, but I used OpenAI embeddings, so that's why 1536. So a table got created, and then I basically inserted a few rows in this table, right? A few vector rows that I'll show you in a different view. So here I created two rows, sample rows. And so in the content, I've hidden the other columns like ID. In the content, I added some sample text, I'm doing good, how about you, and a vector representation of the sample text. We'll we'll get to know how to get this vector representation of the English text, and then another row which says let's go to a mall and spend the day today, and a vector representation for that English. Now essentially I'm going to query this table with an input text and a translated vector of that input text, in fact, and I will do a similarity search on this vector data column, and instead of searching on this English content, we'll search on the vector mathematical representation. And apparently what will happen is that the nearest vector to the input vector will come on the top, and we'll see the result of that query also, that I'll show you. First, let's go to creating a vector. So let's say we want to create a vector for let's say the input is how are you doing, and we want to create a vector for it. So we'll call the OpenAI API, embeddings API, and we'll try to get the vector representation of it. So here in the result you'll see the vector array. We'll just copy this entire vector array and try to query this table using another select query, which is this that I wrote. So essentially I'm just selecting the content, and I'm searching my input vector representation, which I'm going to replace this with what we got from our Postman query against the OpenAI embeddings there, here. And I'm searching this vector as similarity, and then I'm going to order it by the similarity descending, and I'm going to limit it to 5 results. So again, when the input vector is being searched upon against the vector data column, whatever entries are there in this column in the database, and then it'll give me the similarity score ordered by similarity score descending. So we'll run this query. Now essentially what is expected is that for a question like how are you doing, an answer similar to how are you doing, which makes sense, should come out instead of some other answer, or at least the relevant answer should come in the top. So we'll run this query. So as you can see, the query ran, and for a question how are you, the answer I am doing good, how about you, has a higher similarity score of 0.90 instead of the other one, which is let's go to a mall and spend the day today, which has a similarity score of 0.769. So again, apparently what happens is that instead of searching on the English content against the input English, you search it on the mathematical representation of that English content, and your similarity scores come, and accordingly you propose this as the answer to the question rather than this. So that's how even ChatGPT works, or any other vector powered GPTs work. Now let's create a question for this answer, and let's see if the this answer comes on the top for the next question. So let's change the question to something like, I have another question already made here. Okay, so this time the question is, what should I do for fun today? I'm getting bored, right? So you would expect let's go to a mall and spend the day today should come up for that question, rather than saying I'm doing good, how about you, right? So let's first generate the vector for this input, again using OpenAI embeddings API. So again, we'll take the vector representation of this English question, and we'll go and change our query with this vector representation. And we'll run it again. This time we are running it for the question, what should I do for fun today? I'm getting bored. So we'll run it. So as you can see now, let's go to a mall and spend the day today comes up as the first row, and the similarity score is higher than the other one. So this one has 0.83 and the other one has 0.77. So again, concluding by saying that the search is done as a similarity on the vector column rather than the content column, and that's how vector databases work. These databases are highly optimized to search on this vector data types, and that's why they have a serious advantage over anything else like indexes, so on and so forth. Now that we've understood how vectors work, we'll go to a sample application that I built. And before we go to the application, let me tell you that this application is nothing but a replica of ChatGPT. However, this is built to chat against a document that you have. Now, this can of course be scaled to a series of documents, multiple documents, a directory of documents, so on and so forth. But this time I just took a sample document I just copied some data from Wikipedia on Boston. So anything and everything about Boston from Wikipedia, I just created 8-10 pager document like history of Boston, settlement by Europeans in Boston, revolution in Boston, Boston Tea Party, so on and so forth. It's just Wikipedia data on Boston. I created this document. Now we're going to chat this document in our GPT application, but before that we have to again use vector database for that application, and this document needs to be chunked, and each chunk needs to get vector embedded. So again, how we saw it before, each of these English pages need to get chunked, and each chunk will get vector embedded and then get housed in that vector database, and then we'll query that vector database which has chunks of Boston document and the vector representation of each chunk, and that's how we will get the answer to our question if we ask anything to the application about Boston from the front-end web application. So this is the document that I fed into the application, and let me show the application. The application was built in Node.js runtime. Basically, before building the application, created a set of vector tables. So again, vector table got created. This time I created a function rather than writing a select query. I created a match vectors function, which would match the input embedding query with the column, and then the actual select within the function. Again, it's selecting on similarity score, and it's ordering based on the vector table embedding versus the input embedding. This schema ran and created a table. And let's go to Superbase again this time. This time we'll go to another table which the application uses, which is vector table. So this vector table got created, and through the application I inserted all this data on Boston in this table. So as you can see, the content column has the chunks of Boston. This is that PDF document that got chunked. Then there's metadata column as well, but we'll focus on the embedding column, which is the vector representation of each of those chunks in the Boston document. Now again, going back to the application, once the table and the function got created, let me also show you the function. Here in the functions tab, the match vectors function got created when I ran the sequence of SQL statements there, and before that there was an extension also, which is the vector extension that got enabled, which is this vector extension. Let me show you the this is that script that I ran here in the SQL editor for Superbase to basically build the DDL. This is nothing but the DDL, data definition, for the table and the matching function that I showed. So once this is done, then you can uh, let's go back to the application, and I'll just quickly walk through the code. So this application is built on Next.js. It's a full stack web application framework which can help you build fantastic uh, multi-page architecture applications. It is full stack in a way that you can write serverless functions that can scale infinitely. They can run on the server or on the edge as well, and of course the client side pages also you can write in Next.js. It's built on React.js library itself. So the client side web page is pretty straightforward. Uh, it has a set of JSX. The messages appear, and I've used the use chat from AI React to handle input, change, and handle submit for the chat functions. And essentially it calls Edge API, which is this chat API, which does the main job for us. So first it takes the input request, and that request contains the user question. It then creates a client for the Superbase. It hooks up to the Superbase project that we created here and the table. And then it basically creates the vector embeddings in that vector table, and it uses the match vectors function for the input embedding to be matched against the embeddings already present in that table. Before going further, let me also show you an additional step as a prep step, which is to run the script actually. So the script will actually do the one-time seeding of that vector database using that Boston PDF document. So as I said before, it'll go through the Boston PDF document, it'll chunk the document, and it'll create embeddings of each chunk and then store it into that vector table table of ours, the vector table that we created in Superbase for us. So once this pre-seed step, the script runs, you see this table gets populated. So that's when you know that its application is now ready to be run and queried against this table. So we'll go back to the application, which is this route, the serverless API. Now this can run on the edge as well, as I already said before. Now what it's doing is that it's taking the input English text, converting it into a vector, and then running that match vector function to basically compare it with the other vectors in the table and find the closest comparison. As you can see, it's using retrieval augmented generation, and it's getting the top 4 rows. So whichever top 4 rows from the vector databases match, it will concat all that, and it'll use that to send to OpenAI API, and it'll give it some instructions with the role system saying that you're a helpful assistant that provides answers to user question, and then it gives the content. So it's basically joining the first 4 retrieved vector matched rows from Superbase based on the input vector representation of the English question, and then OpenAI API responds with the answer, and it'll stream the answer back to the client. So we'll run this application now. In fact, it's already running. So we'll go ahead and ask a question to this application, and we'll try to chat this Boston document. So here's the application, and I already started asking it some questions, but let's ask another question to it. So let's ask, what do you know about Boston Tea Party from the document? And this Boston Tea Party should be somewhere in the document here. So as you can see, it's already there in the document. Yeah, so it started responding. It responded to Boston Tea Party. This response has come from the document that we passed. Let's find something in the document and then go back and frame a question to ask it. Let's find something unique from it. Okay, let's ask a question in relation to this. In 1822, citizens of Boston voted to change the official name from Town of Boston to City of Boston. So we'll ask something regarding this to the application. We'll ask what happened in 1822 with regards to Boston's name. So depending on the where your API is hosted, the latency will follow through. So as you can see, it has started streaming the answer back from OpenAI API, and it says an important event occurred in the name of Boston. It used to be called the Town of Boston, but then citizens voted to change the name to the City of Boston. So as you can see, the answer is coming from this document, of course in a natural language format, which is what OpenAI does. So again, this application, this GPT application is powered by vector database, Superbase, that I spoke about, and it's basically querying this vector embeddings data based on the input vector, which is nothing but this application takes the input question, like what happened in 1822, and creates a vector embedding of this question, and then compares its vector embedding with the vector embeddings that are stored in the database, and that's how it responds back. So that's how vector databases work. They are a serious advantage to GPT applications. They can easily be scaled to enterprise grade, to support enterprise grade applications, and I think have a brilliant future in AI at large. Thanks for being a part of this session. Thank you.